Hi everybody, this is Sword/Maths Tutor, and this is a video which should be used by people who are interested in integration, and they do exist, everybody. It's probably aimed at A-level more, the A2 bracket for UK students. It assumes an understanding of integration, but is going to go through integration by substitution or changing of the variable or u substitution. That is all the same thing, and we're going to look at two things, which is how do I pick the u in my u substitution and how do I convert it. So the first thing is finding u, and there are two main guidances for you. The first one is that we have, I'm looking in this box here, and well, you'll have to excuse the tapping, that's just me changing colours, because hopefully the colour coding will help with some of your recognition of what I'm looking at. Is that if I've got a function like this, part of it, if I can dy dx it, as I've done here, turns out to give me this answer here, which is at the front of the main part of the function. There is some link between those two functions, or there's an apparent link between the two functions. Sometimes that doesn't work though. So what we're looking for here is a function within brackets raised to some sort of power, or a function underneath some sort of a rooting function, square root, cube root, whatever it may be. It would be the power to which e is raised to, and likewise that can be the inverse 1 over, that's, well, those three situations, and that will generally be, that's the idea. It's part of the function embedded within the main function, if that hopefully makes some sense. Okay, now we found how to find the u part of the u substitution. This is the formula that we're going to be using. Now, very specifically colour coded this, and let's just find an appropriate colour. So it's the integral of a function dx equals the integral of the same function here. I need to find dx du, and if, as you can see, I've put them in the box here. If I have those two things, then the new integral becomes du-able, and that hopefully will make a little bit more sense in a second when I do an example for you. So in essence what we have to do is firstly identify u, then we have to process that, and we have to gather together the bits that go into the new integral, and what we're trying to do is essentially go from something that's hard and make it into something that is easy. That is in essence what y substitution is. Okay, so here we go. Let's have a look then at an example. So we've got 3x squared and in brackets x cubed plus 5 to the power of 7, and it may very well bring you out in a cold sweat at this point, but it's not to worry, because we just have to go through a process. First thing we're going to do is find u. So two ways of doing it, as we said in the previous part of the video. I'm looking for some sort of embedded part of the function, so I'm thinking here that it might be x cubed plus 5, because that is the bit, let's just highlight this, they are embedded in the brackets. It's this bit here. That's looking quite good actually. So that's the one way, and also if I dy dx that function, it gives me that as well, so I get sort of a double whammy on this one. So let's give that a go. So now that I've identified it, I'm going to make a note of that u is x cubed plus 5, and the very next thing I do is I roll straight into du dx. I differentiate it, and I know that I get 3x squared. Now you may have noticed that I've got a du dx, and in my final formula I've got dx du. Is there a simple way that I could convert what appears to be very similar one to the other? And the answer is yes. I just invert and let's put it in the right colour, I just invert du dx, and so therefore I get dx du. In other words, I've just flipped that thing. Flip not being a mathematical way of talking about particularly, and if I invert 3x over 2, that becomes 1 over 3x squared. Did I say 3x over 2? I meant 3x squared. 1 over 3x squared. Okay, do I have the component parts I need to start constructing my new formula? Well, I've got my dx du, yep. I have my original function, yes I do. Okay, so let's see what we get. So it's just, I'm going to put a sort of a partitioning line up here, and I'll try and keep everything in the colours as I've written the formula up the top here. So we've got the integral of. Now, I know that that is fx. I also know that I've substituted y into part of it, so I'm going to sort of do that substitution. In fact, I'll tell you what, I won't do that. Let me just, I'm going to write this as it comes, and then I'll do it. So I've got 3x squared x cubed plus 5 to the 7. So in my formula, as I construct it, that's this bit here. And then I'm going to put in my dx du, which is this bit here, and so that is 1 over 3x squared. And because I've got the yellow and the red bit, effectively, I now know that that is du-able. Okay, what can I do now? Well, what I can do now is, I can see there's a 3x squared there which cancels with that 3x squared, and I also know that my x cubed plus 5 is in fact u. Tidying that up, that means that I get is the integral of u, this bit here, to the power of 7, and it is du. I've done it, I think. Well, what would I rather integrate? That or that? I'm going to go for that. Okay, so the integral of u to the 7 is, I'm just going to go for a single colour now, everybody. So the integral of u to the 7 is u to the 8 over 8 plus my constant of integration, and now I just put back in this function here, which gives me x cubed plus 5 to the power of 8 over 8 plus my constant of integration, and that is the process of u substitution. Okay, one other example just to hopefully reinforce what we've done, and you'll notice that I've put my processing of the formula up here, the conversion. So we've got x, 3x squared minus 1 to the power of 4 dx. Okay, we're going to just step through what we would do. First thing is, if I look for something within the bracket to a power, it appears to be 3x squared minus 1. If I integrated that, that wouldn't give me x, so that hasn't worked, but it is buried inside the function. It is, let's just highlight this, that part of the function is in a bracket raised to the power of 4. So I'm going to pick 3x squared minus 1 to be my u. So okay, let's just pick that and let's note it. U equals 3x squared minus 1, and I take the du dx of that, and that gives me, well, gives me 6x, which is looking nice and clean and easy. And then just to keep it in the colour coding, I do my inversion of that, and dx du equals 1 over 6x. Okay, I've got the dx du, which is in the formula here. I've got my original function, which is in the formula here. So therefore I can now have a stab at putting it together. Okay, so here we go. So it becomes the integral, and again I'll keep it colour coded for you, of fx, which is going to be x. Now I'm going to do, at this point, I'm going to do the y substitution straight away. I know that that can go straight into this bit here. That's one step that I would encourage you to do straight away. It makes life a little easier. U to the power of 4. And now I need this bit, dx du, and that's 1 over 6x. And because I've now constructed that, I can say that that is now du. Okay, going to a single colour now. The x's cancel. I'm left with 1 over 6 here, which by the rules of integration I can now put out the front of the integral, so it becomes 1 over 6 the integral of u to the 4 du. Now, so how does that all bowl out? So I integrate u to the 4, go through the integration process, and that gives me 1/6 times 1 over 5 u to the 5 plus a constant of integration, which, taking that further, gives me 1 over 30 u to the 5 plus the constant of integration, which now putting the u bit back in, so I'm putting in 3x squared minus 1 back in, becomes 1 over 30, and I'll just put it in a bracket because I think it looks a bit neater, 3x squared minus 1 plus the constant of integration. And that, my friends, is it. 2 examples, hopefully, of a slightly easier way of navigating through U substitution. This has been Saltash Maths Tutor. If you have any questions or you want any more help with this subject, then please post it up and I will reply. This is a part of a series of a few U substitution problems, and hopefully will help you. Good luck, and thank you very much for watching.